Good morning students. Today we are going to discuss about what is data structure and how the data structure which is helpful to our life and how we to organize the data in computer. These things are we are going to discuss. Before we are going to introduction, first of all we should know about what is data. So data is nothing, so it is a raw information collected from different sources. So raw information means, so each and every object, in each and every object we have the raw data. For example, I am a staff of Bishop College, so I have the data like my name, the desk name and department and ID. These things are called as data. So what is data means? A basic information of particular object, that is called as data. In day-to-day life we have different types of data are collected from various sources. The data are processed and it will be kept in some places. When we storing like this, so we face some of the problems like if we load more data, so the processor speed of a particular system will be slow down, and if we dump the data in a particular place without organization, we have a problem to extract the data when I am searching. If we more number of users send a request to same server, so we have the slow down our server process. So these are the problems when I am having the lot of data in our day-to-day life. In real time, so in our human body, so suppose I want to see something that will be registered in our brain. So in our human, so the brain will be considered as a storage. Likewise, in computer, the data is collected that will be stored in particular server which are located in anywhere in the country. That stored data will be transformed, and then if we access the data via the network means this data are analyzed and we can extract the data from particular server. So when we store the data, we have faced to some problems, like before I have mentioned as so the processor may be slow down, or we have the difficulty in extraction. So we need the concept of data structure. So what is meant by data structure means we to organize the data in some order so we can extract the data easily. So definition of data structure is, data structure can be defined as the group of data elements which provides efficient way of storing and organizing data in the computer, so we can retrieve the data efficiently. So the data structure which is used to organize the data in a generalized manner. When we store the data in a particular memory or particular server, we perform some operations. These are the basic operations performed on data. The first one is traversing. Traversing means we just look the data, that is whether the data is present or not, like that. So that is called as traversing. This is an example for in real life. We are going to our grandma's house and we visit our grandma's, that is like that. In memory we have a lot of data, whether the data is presented or not, that is called as traversing. Insertion. Insertion is another process in data structure. So if we have a particular data, we can add the data to a particular data structure, that is called as insertion. And deletion, searching, sorting and merging. So these are the key operations that are performed on a stored data structure. So today we are going to discuss about two kinds of data structure. One is linear data structure, another one is non-linear data structure. Linear data structure means the data can be organized in a linear way, that means sequential order the data can be stored. For example, for linear data structure is stack, queue, linked list. So these are the real-time examples are shown here for linear data structure, in which the elements are accessed only in the linear order. One by one we can access the data. In non-linear data structure, the data are collected in a hierarchical way. Example for non-linear data structure is tree and graph. Now we are going to discuss about a linear data structure, stack. So stack is a linear data structure which contains ordered list of elements of same data type, and it follows the principle of last in first out. So let us consider, so we have the elements like that. So we have the data like that. So in the data, so last in first out means, suppose I want to wear this. So for example, so I put in stack data structure, one element can be inserted only at a time, only one element will be inserted. So likewise the data is inserted in our memory. So here, so the stack is follow the principle of last in first out. Suppose I want to remove the element means the element that is inserted is last, which is removed first. So the stack will follow this principle. So for example, we have the books are arranged like this. Suppose I want to this violet book, so I can remove the first book, second book, third, and then after that I can access the violet color book. So the stack which is follow the principle of last in first out. In stack we have one variable that is called as top. So the element which are in the top place, that is called as top, and then we suppose I want to push the element, that process is called as insertion. Suppose I want to remove the element from the stack, then it is called as deletion, or otherwise it called as pop operations. Now we are going to perform that is some operations on stack. So there are four kinds of operations we can perform on stack. One is push. Push means we can add an element to a stack. So if the stack is exceed its size, some condition will be arrived. For example, I have the capacity of 5 liter jug. If I want to put it in 6 liters means the 1 liter will be overflow. Likewise in stack, so if we insert the element beyond the maximum capacity, it will go to the overflow condition. Likewise in pop. Pop means remove an element one by one from the stack. So the pop will be, the item will be reverse order, it will be popped. Already we have told that stack is performed on last in first out. Last in first out means the element which is inserted last will be removed first. If there is a element, we can remove the element. If there is no element in the stack means we don't have element to remove it, that condition that is called as underflow. Another one is peak or top. So the peak or top which retains the top value in the stack. If we have the 3 elements, so the top value will be 3. If we don't have the top elements in the stack, then top value will be 0. And then is empty, which is used to check whether the stack is full or empty. The first operation, push operation. So push operation means we have put a new element into the stack, that is called as push operation in step 1. So this is a algorithm for push operation. In step 1, first of all we check whether the stack is full. That means there is any place to insert an element. If the stack is full, produce an error. So which error will be produced? If the stack is full, overflow message will be produced. If stack is not full, then the top value increment by 1. So the pointer will point the new location. The particular new location, the item will be placed. After the item will be placed on the top, so the stack pointer will be written. So this is a procedure how to insert an element in a stack. Next one, so algorithm. So algorithm for stack is here. Now, so algorithm for stack, push, stack, maximum, top, element. So here stack represents our data structure, maximum size of a stack, top element of a stack. LE represents element, the element we are going to insert it in the stack. First of all we check if the top equal to maximum, that means that stack is full. We are going to check whether the stack is full. If top equal to maximum, then print overflow and exit. So the control will be exit. If there is a place and then top value incremented by 1, stack of top, the element will be placed. case 1. So let us consider the stack which have two elements A and B. The maximum size of the stack is 4. The top element, so there are two elements. The element which is inserted last will be in the first position. So the top value will be 2. Let us consider maximum equal to 4, top equal to 2. The element I am going to insert it as C. So here step 1. So first of all check top equal to max. Top value is 2, maximum value equal to 4, 2 equal to 4. This condition is false. So if this condition is false, then goes to the else part. In else part, top equal to top plus 1. So top value is 2, 2 plus 1. So the new top value will be 3. So the pointer will be moved here. And then after that incrementing the top pointer, stack of top equal to element. Stack of top means stack of top value is 3, element equal to C. So the 3 will be assigned into the third location. After that the control will return. This is in the case. This means we have the place. So I have the place here, so I can wear the bangle like that. If we have the place in the stack, so there is a place we can insert it. Suppose next consider the next case. Case 2. So here consider this case 1. Let us consider the stack with have 4 elements A, B, C and D. So top value equal to 4 and maximum size of the stack is 4. So now I want to insert an element E. First of all I check the condition if top equal to max. So top value is 4, 4 equal to maximum value is 4, 4 equal to 4, condition true. So if the condition is true, then it prints overflow. That means we don't have space to insert an element, so we come out. So and then return. So this is the way of inserting element in the stack. The way of inserting element in a stack, that is called push operation. Next one is pop operations. Pop operation means we are going to remove an element from the stack. That is called as pop operations. So in the pop operation, before we are going to remove an element, whether the stack is having element. Yes, I have the element. If the stack having the element, then remove it. If stack is empty, then we can't remove. So the error will be produced. The error is underflow. If there is no item in the stack, so it will produce an underflow error. And then if the stack contains element, so in stack the top element only removed. So the top value decreased by 1 and then return. And this is an algorithm for pop the element from the stack. So in the pop stack represents a data structure, top represents a top value item I am going to represent. If top equal to 0, that means there is no element in the stack, it will print underflow and exit. Otherwise, item equal to stack of top. Stack of top, the element which is in top will be assigned to item, that means item is removed. After removing that, top value will be reduced by 1. So top equal to top minus 1. So let us consider the case 1. So let us consider the stack, that is the stack contains for maximum size is 4 and we contains 3 elements A, B, C. So the stack contains 3 elements, maximum value is 4. Step 1, check top equal to 0. So here the top value is 3. 3 equal to 0, condition false. So it will go to the else part. What is in else part? So item equal to stack of top. Stack of top value is 3. What is in stack of 3? Stack of 3 is C. So the item C, that is item C will be removed. And then next one, top value will be decremented by 1. Top equal to top minus 1. Already we have top value 3, 3 minus 1, 2. Now the top value will be. So after removing the element, so this stack will be represented like this. So next one, case 2. In case 2, so here this is the stack. So I don't have any bangles here. So I don't have any element in the stack. So suppose I want to remove the element from the empty stack, the error message will be produced. That the error message will be underflow. So let us consider the stack with the size of 4 and then top equal to 0, maximum equal to 4. And then check the condition, max equal to 4, top equal to 0. So top equal to 0, 0 equal to 0, the condition is true. If the condition is true, that means there is no element in the stack to remove. So it prints underflow and exit. So these are the two operations that are performed on the stack. So today we are discuss what is data structure, why we need to go with data structure, and we discussed one type of data structure, that is linear. In that linear data structure we have discussed what is stack, what are the operations that are performed on stack. By using this stack, what are the in real time where the stack is applied. So balancing of symbols and infix and postfix, these are involved in theory of computation paper when I convert the parse trees. Another thing, so that is redo undo features. We are that is we realize these features, real time features. Suppose I am typing something in our Word document, suppose I want to delete it, I can use Control Z. Control Z, what it will be done, so the modification that is done last will be removed first, like that. The redo undo features is based on our stack principle. Likewise in browsers, forward and backward buttons that are based on the principle of stacks. Thank you.